Hello! Again, we are solving problems, solving equations, solving linear equations, solving for x. This is a little bit different. This has an x on both sides, it has numbers on both sides. Does that greatly change what we have to do? Not necessarily, but does it make it slightly more difficult for students? Absolutely. But as long as you keep things into perspective, you're fine. Make sure you distribute and combine like terms on each respective side before you start moving things around. Make sure you use either the reciprocal property, distribution, combining like terms. Do what you're supposed to do on each respective side before you start manipulating the entire equation. With that said, is there anything I can do with this? 7 subtracted 8x. Can I combine them? No. Can I distribute them? No. Can I get rid of fractions? No. Okay, that's pretty boring. Same questions I asked. No, no, no. Still the same thing. Nothing changed. So I've got to keep a couple things in mind. One, get everything with a variable on one side and everything without a variable on the other. And make sure what I do on one side, I do on the other. Here's a question that students often ask me. Does it matter if I move all my x's to the left, or does it matter if I move all my x's to the right? And the answer is, whichever is easier for that particular problem. A lot of teachers just like moving it to the x because it helps students just keep it to one side. You can move everything to the right in terms of variables, and then you can move numbers to the left. It doesn't really matter, whatever is easier. And in this case, actually, it's easier to move the x's to the right. And there's a reason why. If I subtract 4x on both sides, then it's negative 12x, but sometimes students will get that wrong. But if I add 8x to both sides, then it's easier for students to grasp that it's 12x. Don't ask me why, it just is. So here's what we're going to do. We're going to move everything with an x over here. That doesn't have an x. Don't move it. That has an x, negative 8x. We're going to move it. Don't worry about the negative 17 for now. Leave the 4x on the right side because that's where we're moving everything with an x. So how do I get rid of a negative 8x from this side? I add 8x. Now, I can't just add 8x to one side of the equation because it's going to imbalance my teeter-totter. So what I do on one side, I have to do on the other. So I'm going to add 8x. Now you can put the 8x over here, you can put it there, you can put it under the 17. It doesn't really matter. But why I put it under the 4x is because since they're like terms, I'm going to line them up because the addition will be easier. If I put it over here, students don't necessarily see this quickly, but if I line them up, it makes sense. So negative 8x plus 8x cancels. It's 0x. 0 times x is 0. It's not 1, it's not x, it's 0. Whenever you add something to something else, whenever you take the opposite of something and you're adding or subtracting, they cancel. For instance, 3 minus 3 is 0. So it would stand for reason that x minus x is 0. It's not 1, it's not x, it's 0. Same thing, negative 8x plus 8x, 0. When you're dividing, you'll be left with a 1. But when you're, don't come up with weird math. So I've got 7. That's a plus 7. It's not a minus 7. Now students are going to see this negative right here and they're going to say, no, Mr. Shahadi, it's a negative 7. If you want to look for the symbol of a constant, a coefficient, a variable, whatever, you look in front. I don't see a negative. That's a plus 7. That's gone. Equals 4x plus 8x is 12x. It's not 12x squared, it's 12x, because a lot of students do make that mistake. And here's my simple logic for it. 4x men plus 8x men is 12x men. That's it. Subtract 17. Now, I've got everything with a variable on one side. I don't need to move the 12x back over there. I'm just going to leave it on the right side. It's fine. I want everything without an x on the other side. I can't combine 12x men and 17 regular Joes together. It's not going to happen. These people aren't the same. I have to get rid of this negative 17 because I don't like it with the x. Now how do I get rid of a negative 17? I add it. But what I do on one side of the equation, I better do on the other side of the equation. Negative 17 plus 17 is 0. Cancels. 7 plus 17 is 24. equals 12 times x. How do I get rid of that multiplication in between the 12 and the x? I divide. 24 divided by 12 is 2. 12 divided by 12 is not 0, it's 1. But it's 1x, and ax and 1x are the same. I'm not going to put 1x, I'm just going to put x. There you go. Now, there is one last thing I should say though. Some teachers find it unpleasant when you put the x second. Some don't care. Some say, well, you got to make sure that you just make it look nice. So instead of writing 2 equals x, you can also write x equals 2. Would I mark either of them wrong? No, because if you got to this step and you said 2 equals x or x equals 2 is the same thing. It's, you know, it's saying, it's like saying, I don't know what it's like saying, but it's like saying something, you know, gambit is cool, you know, x is cool, or cool is, that's a bad example. It doesn't matter. 2 equals x and x equals 2 is the same exact thing. Usually pretty good when it comes to coming up with those analogies, but this time I just couldn't. This one's unpleasant. And there's a couple ways you can do it. You can distribute the 1/4 into each term. You can make it, you know, 1/4 times 16 over x and 1/4 times 60 over 1. It's not as bad as the other one that we did. In fact, it's actually a lot better. Or you can use the reciprocal property, which is you multiply by 4 over 1 on this side and you multiply by 4 over 1 on this side. It's your choice. I'm going to distribute. You can use the reciprocal property if you want to. And as long as we come up with the same answer, it doesn't matter. I can't do anything with 9x minus 5. Can't combine those like terms. 9x and 5 people don't work. Let me get rid of this 1/4 once and for all. So I'm going to distribute this 1/4 into 2 terms, and it's 2 terms because there's 2 different terms in the parentheses. 1 times 16x, 16x, 4 times 1 is 4. As I said, this one's going to be nice in comparison. 1 times 60, is it plus or minus? It's plus over 4 times 1. Okay, that's not terrible. Equals, it's 9x minus 5. And if you do the reciprocal property, like I said, and get the exact same answer, perfectly fine. Reciprocal property is where you multiply this one by 4 over 1, and then you multiply this one by 4 over 1. But when you multiply by 4 over 1, you better distribute into both these terms. This one would just cancel out the fraction. $16 divided by 4, 4 with an x left over, plus 60 divided by 4, 15. Everything with an x should go on one side, everything with an x without an x should go on the other. And the reason is because I can't combine 9x minus 5 because they're not like terms, and I can't combine 4x and 15, 4x men and 15 people because they're not like terms. So I'm going to move everything with an x on one side. And actually in this case it's easier for me to move 4x over here because here I would have to subtract 9x and here I'd have to subtract 4x, and it's nicer to work with positive variables as opposed to negative. So here we go. And by the way, I would subtract, I wouldn't add, because this negative doesn't belong to the 9, the negative belongs to the 5. There's no operation here, which means it's positive. So let's subtract 4x. But what I do on one side of the equation, I do on the other. Now you can put the negative 4x anywhere you want on this side of the equation, but you should generally line it up with its like term. 4x minus 4x, it's not x, it's not 1, it's 0. So many times I have to emphasize that over and over, and there's a reason why, because students will tend to forget otherwise. And it's not necessarily because it's a difficult concept, it's just if you don't practice it enough, you're going to forget. I mean, there's things that I knew how to do before that if I don't practice them in a while, you know, like speaking a different language, I'm going to forget it over time. Same thing with math. 9x minus 4x is 5x, I've got subtracted by 5 as well, equals 15. 5x minus 5. Add 5 to both sides. But what you do on one side of the equation, you do on the other. 5x equals 15 plus 5 is 20. That says 5 times x. How do I get rid of multiplication in between a number and a variable, or a coefficient and a variable? I divide. 5 divided by 5 is 1, which is 1x, or just x. I'm going to move this over here. And 20 divided by 5, that's not 20 subtracted 5, it's 20 divided by 5 equals 4. We haven't done this in a while, so we could always check it. You can substitute everything back in. 9 times 4 is 36. 36 minus 5 is 31. So that side is equals to 31. Yes, that makes sense to me. 16 times 4 is 32. 64. 64 plus 60 is 124. Fourth of 124 is 31. Bam! Checks out. You don't believe I did that fast? I really did do that fast. But then again, I've also been practicing math for a long time. With that said, we're done with this particular lesson. We're going to do a couple special case problems after this. Everything doesn't always come up with an answer. You know how we have x equals 5, x equals 4, x equals 3, x equals 1. Well, we're going to try a couple examples of linear equations where the answers are unusually different. But I'll leave you on that for now. Have a good day for now. Take it easy. Goodbye.